Hello, this video is how do you form half equations. I've said on other videos of mine that this is a follow-up video to my ionic equations video. Ionic equations and half equations come hand in hand. So if before you've started this, two things. One, if you want to do half equations for electrolysis, that is a separate video. Second thing, if you're wanting to do normal half equations, not in electrolysis, you are in the right place, but I would suggest watching my ionic equations videos first. First up, let's just remember or remind ourselves where ionic equations come up and thus where half equations come up. Now, they come up in electrolysis, as I've said, but in the electrolysis topic, I've done my own video, literally titled Half Equations Electrolysis Edition. In this video, we're going to look at displacement and we're going to look at salt reactions. Now, displacement is where you have a more reactive metal displacing another. Salt reactions are any of the salt reactions, so acids plus a metal, acids plus a base, so on and so on. Salt reactions can be turned into ionic equations. Ionic equations can be turned into half equations. Okay, so let's start with displacement. And I'm just going to finish off the equation here. We've got calcium nitrate being added to zinc. Sorry, we've got calcium being added to zinc nitrate. Now, the calcium would displace. Actually, I'm just going to rub this out and move this whole thing over. So we had calcium. Okay, so calcium plus zinc nitrate is going to give you calcium nitrate plus zinc. Okay, so from here I'm going to really quickly do the ionic equation. Again, not going to talk you through that in full because it comes up on a different topic, on a different video. So we have Ca plus Zn2 plus NO3 minus. It's going to give you Ca2 plus your nitrate ion again and zinc, and we're going to remove the spectator ion. Okay, so therefore our ionic equation will be Ca plus Zn2 plus gives you Ca2 plus Zm. Okay, so that is your ionic equation there. We're now going to split that into two half equations, and we're going to look at one species at a time. So first of all, let's look at what happens to the Ca on that side of the equation and Ca2 plus on the other side, and write a half equation that represents it. Okay, so we've got Ca. It then turns into Ca2 plus. Okay, so we need to decide what is happening here. Now, calcium is a neutral atom, and that calcium is turning into a 2 plus ion. So for, and I'll write that out actually, this is an atom, this is an ion. So how is it changing from a neutral atom into a 2 plus ion? Hopefully you will know that it has to lose electrons. I'm representing that there by E minus. So it is losing electrons in order to become the 2 plus ion. Okay, so this is an oxidation half equation. Okay, so we've got our Ca turning into our Ca2 plus. Now it has to lose electrons, and we write the loss of electrons on this side. Okay, now we've got a Ca2 plus. Okay, it is losing electrons, and it is losing 2 electrons, and that is your half equation there. Now we're going to look at the zinc and what is happening to the zinc, Zn. Okay, now similarly, but you will see the other way round, we have got Zn2 plus turning into Zn on the other side. So we already started with the ion here, and the ion has got a 2+ charge, which means that it's got more positives than negative electrons. So because this is the reduction equation, now you can see up here I've written oil rig. Oxidation is loss of electrons, reduction is gain. The reduction equation means that there's going to be electrons added, and they are added on the left hand side. So we put plus E minus. Now it is a 2+ charge, so it will need 2 electrons to be added to it, and that is your half equation for zinc. Now looking at some salt reactions, really quick example here. This is lithium reacting with sulfuric acid to give us lithium sulfate and hydrogen. I'm going to write out the equation. Actually, what I'll do is I'll just write out the ionic equation rather than the full balance. Let's just stick with doing ionic and then half equations. Sulfuric acid is H plus and SO4 2 minus. Li plus SO4 2 minus, hydrogen is H2. Okay, we remove our spectator ions. Our ionic equation is Li plus H plus arrow Li plus H2. Okay, that is our ionic equation there. Let's split it into your 2 half equations. Now let's start with lithium. Again, I can do this in all different colours. Let's do lithium. What's lithium doing from this side to this side? Okay, lithium is going from Li into Li plus. So lithium from the left hand side to the right hand side is losing electrons. Oxidation is loss. That is your oxidation half equation. Now oxidation is a loss of electrons. We show the loss of electrons on the right hand side. There is 1 electron being lost because it is a 1+ ion. Now we go back to the hydrogen. Now the hydrogen is going from H plus to H2. Okay, H plus to H2, and it means that the positive hydrogen ion it's got too many positives than it does negatives electrons, so it needs to gain electrons, so therefore reduction is the gaining of electrons. We write the gaining of electrons on the left hand side by putting plus E minus. Now we need to balance this equation. We can't leave it like the lithium one. If you look here, you've got 2 hydrogens on the right hand side, not a charge, 2 atoms, so we put a big 2 here. We now have got 2 hydrogen ions, each needing to gain an electron, so we must put 2E minus there. And they are your 2 half equations for the above salt reaction, lithium plus sulfuric acid. So to summarise everything we've just said on the previous slides, you are looking at ionic compounds here. They are the compounds that undergo many different reactions. In particular, for half equations, we look at displacement, we look at electrolysis, and we look at salt reactions. Now in this video we just looked at salt reactions and displacement. This is on another video. Okay, what you want to do each time on those displacement and salt reactions, do your ionic equation first and then split that ionic equation into 2 and give me 2 half equations, one that shows oxidation and one that shows reduction. Okay, so that is how do you form half equations, particularly looking at displacement and salt reactions. As always, you can rewind this video, pause it before I go through the worked examples, have a go yourself, then play the video and give yourself some feedback based on the rest of the video. Good luck as ever. Please drop me an email if you've got any questions.